All right. Hello, everyone. We're going to give everyone a moment just to get loaded into the webinar, and we'll get started in just a minute. Dr. Steinman, I know you said you prefer Alan. Is it Al or Alan?
Al's fine. Thank you.
Al's fine. Okay, well, good afternoon, everyone. I'll introduce everyone here today as people are logging in. My name is Andrea Coronado, Development Communications Director for TIP of the Mitt Watershed Council, and I will be facilitating today's Icebreaker series. We have over 100 registrants joining us today, so when we get to the Q&A portion of this program, we may have to limit questions to keep our presentation to an hour. This Icebreaker series is free to our community thanks to our generous members and donors, and I am sure many of you are in the audience today, and I thank you for your support. For those of you who are new to Tip of the Mitt Watershed Council, we are a membership-based environmental nonprofit with a mission to protect and care for our water resources here in Northern Michigan. And we work locally in watersheds within Antrim, Charlevoix, Sheboygan, and Emmett counties, and throughout the Great Lakes region. So just a little bit of housekeeping today before we get started. We have all attendees muted during this program to avoid any background noise. If you have a question, please use the Q&A function, not the chat function. It's Q&A. And we'll answer those questions at the end. And surprise, we have a surprise guest who's joining us today, our Executive Director, Heather Huffstetler. She will be joining us after this presentation to field the questions and have a conversation with Dr. Steinman or Alan or Al. If we don't have time to get to your questions due to time constraints, again, we will follow up with you individually, or you're welcome to contact us directly at the Watershed Council. And as always, virtual technology can go wrong. If we experience any technical difficulties during this presentation, we appreciate your graciousness as we work through the glitch. So I am thrilled to introduce our speaker today, Dr. Alan Steinman. He's going to be talking to us today about something we have all been using a lot of lately, road salt. So with that, I will turn it over to Dr. Steinman, and you can start to share your screen now.
Thank you, Andrea. And here we go. Good. Let me just get this out of the way. And thank you, everybody. What I'm going to do today is give you start with an overview of the salinization issue, and then I'm going to migrate into some of the studies that we have been doing in a tri-lake complex in Grand Rapids that some of my students have been doing. One is going to focus on the physical and chemical effects on a local lake. Ellen did that for her master's degree. And then potential impacts to down gradient lakes that Allison did as part of a bachelor's honors thesis. Jackie worked on the impacts to groundwater, and then Noah looked at the effects on macroinvertebrates. And then I'm going to segue at the end to other salinization issues that are facing Ottawa County, where I live, at the southern part of the state. And these, as opposed to road salt related issues, these are natural salt issues that are coming from deep aquifers. So let's start off and talk a little about units. And so when we talk about salinity, we talk about it in grams per liter or parts per thousand. At the far left here, we're talking about the freshwater box. And then we blow that up and we look at it along this gradient all the way to saline ocean water, which is about 35 to 38 parts per thousand. But at freshwater, we're down at this 0.5 to 1 gram per liter. And this is a combination of a bunch of cations. Those are positively charged ions like sodium, magnesium, calcium, and potassium, as well as negatively charged ions, the anions, the sulfate, the carbonates, and chloride. Together, they come up with the total dissolved solids. And when we measure this, we're also looking at electrical or specific conductivity, because those ions are charged, and we can look at that charge in the water, and we measure this in microsiemens per centimeter. In our waters around here, we often, instead of measuring chloride, which takes a special instrument to do that, we can measure this electrical conductivity, because most of that conductivity is made up of the chloride ion. They have a very, very strong relationship between the two of them. And so we'll talk about what that means in just a minute. Again, looking at this freshwater box in the upper left, if we blow this up, looking at this gradient of milligrams per liter of chloride or parts per thousand, we have the standards that have been placed by Canada for chronic exposure to salinity. It's about 120 milligrams per liter of chloride. In the US, it's 230. In Michigan, which I've shown by the Mackinac Bridge, we're 150. So we're a little more stringent than the EPA, but a little looser than Canada when it comes to these, for biota being exposed in the long term to chloride. Now, if we have acute exposure, that's short term and toxicity, Canada is about 640 milligrams per liter. And the US, again, has a looser threshold of 860. So we'll keep these thresholds in mind. I'll repeat them a couple of times, because when we start looking at impacts, we're going to be looking at these standards that are going on with respect to chloride and conductivity. So once again, for chronic exposure, long-term, the state of Michigan is 150 milligrams per liter. EPA is 230. Canada is 120. And for short-term exposure, it's 860 for the US. And just to put this in context, 1 teaspoon of road salt placed in 5 gallons of water, a 5-gallon bucket, comes to that EPA threshold, 230 milligrams per liter. So it doesn't take a lot of salt in water to start having a potential impact. And the reality is we have seen biotic responses, negative biotic responses, at well below these chronic thresholds that are already established. So I would argue, and I think most scientists working in this field would argue equally, that the standards are already too loose and they need to be tightened up to really preserve our freshwater resources. Now, Hillary Dugan at the University of Wisconsin-Madison has been doing a lot of work on this. She did not sample all of these rivers and streams and lakes in the Minnesota, Wisconsin, and Michigan area. She's modeled the impacts based on how close the lakes and streams are to roadways that get salt applied. But if you look at the colors, the warmer colors, the greens and the yellows around here in the greater Detroit area, the greater Milwaukee area, the greater Madison area, these areas that are more urbanized tend to have higher chloride concentrations up to and above 500 milligrams per liter. Remember our standards, 120, 150, 230, well above those regions. So what she's seeing based on her modeling work is that there are already a lot of water resources in our tri-state area here that are well above these federal and state mandated thresholds. So cause for concern. And that's reflected in the fact of how much salt we're applying. From 1950 to 2014, the last national standard that we have here, the road salt application has increased by 23 million metric tons. And if we graph that out, you can see what that looks like over time. In 1975, we were applying 8 million metric tons. In 2015, it was up to 32 million metric tons. Part of that is because salt is relatively cheap and it's effective. And when we have ice on the roads, we don't want to drive on that. We want to get rid of it. So salt is being applied at a fairly dramatic rate to deal with that. And up until recently, we really didn't think about the ecological implications associated with that salt application. If we look here at what's going on with respect to salt usage in Minnesota, we can see that in terms of chloride in metric tons, road salt is by far the dominant source. But there's also salt coming from other sources, like excretion from livestock. It's part of the manure and the urine associated with livestock. It's in synthetic fertilizer use and also in household water softeners. So if you're in an area that has hard water and you're softening it artificially, there is going to be salt associated with that. Often sodium is applied or with chloride. How much salt is being used? Oops. If we look at 2017 to 2018, in Michigan, Wisconsin, and Ohio, we can see the total tons vary between 570,000 to 933,000 metric tons of salt. And what that, if you normalize that by road mile, you can see that comes up, think about this, 19 tons per road mile in Michigan. That's a lot of salt per mile that's being applied. It's even worse in Ohio, where it goes up to 21.5. Wisconsin, which is way out ahead of us in terms of the recognition of the impact of salt, has already taken steps to be more conservative in its usage and providing recommendations to the homeowners and to their Department of Transportation on how salt can be applied in a more efficient way. And we'll talk about that at the end of the presentation. It's also costly. Even though salt per unit mile is relatively cheap compared to other sources, Wisconsin still spent $48 million over that time period in applying salt on a statewide basis. So if there are ways that we can reduce salt usage, have alternatives, not only do we help the environment, but we can also save money. Salt has lots of impacts to freshwater ecosystems, not just to the biota, but the chloride is corrosive. So it's going to eat away at your pavement, at your concrete, your cars, pipes, appliances, et cetera. So there's also going to be infrastructure impacts associated with chloride application. And most of the salt that is applied is in the form of sodium chloride because that's the cheapest and most abundant. It also has detrimental impacts at virtually all trophic levels in our waterways, everything from the bacteria and algae at the base of the food web up to fish. We see decreased reproduction, increased mortality, and a decline in overall biodiversity in those sites that have been studied with respect to road salt. And as I mentioned earlier, we see these impacts below the chronic thresholds of 230 milligrams per liter for the federal standard and 150 milligrams here in Michigan, particularly zooplankton. A lot of work has been done on zooplankton, and several of the genera of zooplankton are impacted at concentrations below 100 milligrams per liter. And zooplankton, of course, are an important food source for the higher trophic levels for the fish, and also important in terms of predators of the algae in case you want to minimize algal blooms. So losing the zooplankton has a significant ecological impact in lakes and rivers. So let's talk a little about lakes and what goes on in a normal year in a normal lake in Michigan. We know that when lakes stratify, and that, for example, in the summer months, we have the warmer temperatures at top, the colder temperatures at the bottom, and there's a thermal stratification that goes on. This thermocline separates the warm water at the top, the colder, denser water at the bottom. And what happens during the fall and the spring, these lakes turn over. They're dimictic. They turn over twice a year. So what happens, for example, in the fall, that top layer starts to get cooler. And what happens, it finally reaches a temperature that's equivalent to the bottom water. We say that's isothermal. And then all it takes is a little wind to mix that lake. And it's important for the lake to mix because it mixes the oxygen throughout the entire water column. It mixes nutrients throughout the entire water column. It helps replenish the lake. So we want this to happen. Unfortunately, when you start adding salt, that salt is dense and it sinks to the bottom of the lake. And now you have a density gradient in the lake, not a thermal gradient, but a density gradient. And even if the lake is the same temperature from top to bottom, if it's isothermal, it's no longer going to mix because this density gradient is so much stronger than the thermal gradient. There isn't enough power in the wind to mix the lake. And when it doesn't mix, what happens at the bottom is that anoxia, or low oxygen, dissolved oxygen, starts to be depleted because the organisms down there are still respiring. They could be bacteria or fungi, but they're sucking the dissolved oxygen out of the water column, and there's no replenishment because the lake's not mixing anymore. Also, nutrients will accumulate at the bottom, and also gases that are anoxic gases like methane will also accumulate down there. So it starts to become this noxious bottom water. We don't see it because it's down below, the top surface layer. So it's a ticking time bomb that's just down there, all being driven by the salt layer that's being applied and sinking down to the bottom of your, normal lake. So with that background, I know everybody's now all excited and, feeling good about their lakes. I'm going to talk a little about some of the research we've been doing on these 3 lakes in the east side of Grand Rapids in Kent County here in Michigan. There's a major Michigan highway, the Beltline M44, that goes past Church Lake, and we're going here from east to west, north to south. And Church Lake has a tributary. There's a median here in the Beltline, and there's a storm drain, several storm drains in there, and it feeds into a culvert, which dumps into this tributary, which then feeds into Church Lake. And there's standing water that connects these. There's no direct tributary from Church to Middleborough, Middleborough to Westborough. It's just sort of a slow-moving wetland that connects all of these on the surface. So the first study I want to talk about is Ellen, who took a look at what the physics and the chemistry was of Church Lake. And so her thesis was focused on one of the questions she answered was, how does this salt concentration running off the beltline affect the water quality of Church Lake? And so we can blow up Church Lake here. Here we see is with respect to Grand Rapids. You can see that there are homes around the lake, but it's not densely populated. This is a pretty tony area of Grand Rapids, and so the homes are widely dispersed and they have large lawns. Here's the tributary. You can't really see it because leaf is on this point, but you can see the belt line, you can see the median, and then that feeds into this tributary, which feeds into Church Lake. So just some facts about Church Lake. It's located on the east side of Grand Rapids. It has the salt pollution, the tributary you can see here. And the chloride concentrations are usually way above 230 milligrams per liter, exceeding the thresholds, particularly in the deepest part of the lake, which is around here. What Ellen did was from August 2020 to April 2022, she went out to the lake monthly to 2 sites, the deep site, which is about 50 feet deep here, site 1, and then a shallower site about 18 feet at site 2. And she would take out the YSI and measure water quality, also the clarity, total phosphorus, dissolved phosphorus, chloride concentrations, and metals. And then she went into the tributary, the inflow, twice a month during the storm and base flow, and took measurements there as well as looked at the outflow. And like I said, there's really not a discrete outflow. It just kind of sheet flow out of this west end of the lake towards Middleborough Lake. Now, I mentioned we measure conductivity because it's easier to measure than chloride. And here you can see the relationship between the two. Chloride makes up most of the conductivity, but there are other ions. So that's why conductivity is a little higher than chloride. But you can see that they respond in tandem throughout the year. And again, you can see the EPA and the Michigan standards for chloride thresholds in the lake. And then if we regress the two against each other, conductivity on the y-axis, chloride on the x-axis, you can see the really tight relationship between the two. So we have a lot of confidence that when we measure conductivity, we're getting a really good proxy for chloride concentration as well. This heat map shows the chloride concentration. Now remember, excuse me, that we're looking for anything below 150 milligrams per liter for the Michigan standard. At the bottom, we're exceeding 300 milligrams per liter of chloride based on our chloride concentrations. And then if we look at total phosphorus, because the lake's not mixing anymore, the phosphorus concentrations are up to 5,000 micrograms per liter of parts per billion. For those of you not familiar with phosphorus, Lake Michigan's 1 to 2 micrograms per liter. Even a heavily polluted lake in Michigan, we can use Lake Macatawa around Holland area, is at 100 to 125 micrograms per liter, and we are at 5,000 at the bottom of this lake. And if you look at the surface of the lake, it looks perfectly fine, high water quality. So there's a huge ticking time bomb. If the lake ever did turn over and all this phosphorus got to the surface, we would have massive algal blooms as the phytoplankton responded to this kind of nutrient concentration. And who knows how prevalent this is around the state. This is one example, and we're very concerned that it might be much more ubiquitous than we know. So if the lake ever did turn over, not only would we disrupt the lake hydrology, we would expect that salt concentration getting up to the surface where there's enough light for the algae to grow would have an impact, and it would certainly alter the water chemistry. And we think all that phosphorus would then result in these massive algal blooms, and we don't want to find out. So if we think about solutions to this problem, certainly we want to deal with the phosphorus first and then start worrying about the salt, because the worst thing that could happen is remove the salt, even if you could, and then have the lake vulnerable to turning over and have all that phosphorus reach up into the surface. And this is a lesson that goes beyond Church Lake. This is something we need to think about in a more systemic way. So as I mentioned earlier, we don't want to do away with road salt. It reduces accidents by 78% on average, according to MDOT. But we want to make sure that we apply it and maintain it in a much better way, in a much more efficient way, in a more effective way, so it doesn't cause these kinds of water quality impairments. Currently, anybody who's behind a truck that's applying salt knows that you stay out of the way. I mean, their number one criterion is to get that salt on the road as fast as possible. And so it's an education process, and it also requires resources, no doubt about it. So in conclusion, for Ellen's part of the study, we saw that high concentrations of chloride prevented the lake from turning over in its deepest part. As a consequence, the phosphorus accumulates at the bottom of the lake. And then the removal of bottom phosphorus should precede addressing the chloride issue to avoid that phosphorus stimulating algal blooms. So now I want to go to Allison's study. Allison, again, this was a bachelor's program. She's an undergraduate student. I'll get the words out. And she wanted to look at whether salinity in Church Lake was extending to Middleborough and Westborough lakes, the lakes further down gradient. So she sampled 3 sites in Church Lake, 4 sites in Middleborough, and 3 sites in Westborough. So she tried to sample the deepest part of each lake, as well as where she thought the inflows might be occurring. It's really hard to tell because of the diffuse sheet flow, and where we thought the outflows were coming from Middleborough and Westborough lakes. And again, we used this regression. She measured conductivity using this exometer as a proxy for chloride concentrations. And what she found, we're looking here at first at Church Lake, the one that's closest to the belt line. And we found that the conductivity levels were highest at the deepest site, which makes sense. That's where the salt is going to be sinking, and less so at the shallower sites at the inflow and along the southern border. Now, conductivity, we like to see conductivity in our lakes here in Michigan below 400 microsiemens per centimeter. We start seeing impacts at about 600. And here in Church Lake, even in the shallow areas, which had lower conductivity, they're still well above that 900, well above the 600 microsiemen threshold. And now we go to Middleborough Lake, and we see a very similar trend as in Church Lake. The highest conductivity levels, the highest chloride concentrations as a consequence, are in the deepest part of the lake, in this case up to 1800. Interestingly, the conductivity got higher as we move further away from Church Lake, further away from the beltline. And they were lower along the shallow areas, but still much higher than we would like to see. And then finally in Westborough, the same trend, the deepest lake had the highest conductivity. It went down a little from the Middleborough, but still well above what we'd like to see. And also the shallow areas were lower, but still well above 1,000 microsiemens per centimeter. So clearly we're seeing a problem in all 3 of these lakes, even though the westernmost lakes, Middleborough and Westborough, are nowhere near the beltline. So we knew from Ellen's work that Church Lake road salt runoff was a source of chloride, but we weren't sure what was going on in Middleborough and Westborough. Other sources for the chloride could be the overland flow coming from Church into Middleborough and then Middleborough into Westborough. It could be leakage from septic systems. That there were 2 homes on the north side of each lake that were still on septic. And it could also be groundwater, which led to Jackie's project, which I'll show you in a minute. But I think it's pretty clear from Allison's research that the chloride is definitely getting into these systems. The question is from where. So here's Allison, and here's Jackie, excuse me, and she had 2 questions she was trying to answer. How did the high conductivity reach all 3 lakes? And is groundwater the source of this high conductivity? So we had a series of experiments. Jackie worked in my lab for 3 summers as an undergraduate, and her first 2 was doing experiments in the lab. And she took this very sophisticated setup where she took water from the lakes, in this case from Church Lake. She added into the sort of manifold drip plate, which then dripped onto sediment that she took from the tributary and from the floodplain. And she collected this trough had holes at the bottom. So the chloride could then go through the sediment and went drip down into the effluent collection bin or run off into a runoff collection bin. And the question was the sediment holding on and retaining the chloride, or was it releasing it after we added chloride? And then when we rinsed it with fresh water, does that chloride, if it was retained, does it then get released into the system, or does it stay retained into the sediment on the tray? So these are the three experiments, phase 1, 2, and 3. We did them in sequence. Phase 1, we took water from the surface of Church Lake where the chloride concentration was relatively modest, 150 milligrams per liter, just to standardized conditions. Then we took water from the deepest part of the lake, which was impacted at 550, to see if the sediment retained the chloride. And then we did a rinse afterwards, going back to the surface water of the lake to see if the sediments held the chloride or released it. And we did this in 3 different transects, 2 in the tributary flowing into Church Lake, 1 as it was flowing out. And then we took sediment from inside the tributary itself, and then 0.5 meter away from the tributary in the floodplain and 3 meters away from the floodplain. I'm just going to show you these results. As we expected, when we did the ambient conditions, there was very little release or retention. This was the 150 milligram, and basically this was just to wet the sediment. So it was ready for the next experiment, the actual application of the salt water. And we saw, much to our surprise, that the sediment was really good at retaining chloride. Chloride is what we call a conservative ion. It's not actively taken up by biological organisms, but it's clearly retained by the sediment in the system. And then the question is, after we apply the recovery water, does that chloride then get rinsed out, or does it stay in the sediment itself? And we saw that in general, there was release going on in these sediments. And what this means is that once these sediments get basically chloride exposed and retain it, it can then release chloride throughout the entire year. Even in September and October, long after any salt has been applied for snow and ice in the previous winter, it's still at every rain event can be releasing some of this chloride. So this problem of the chloride contamination is a year-round problem. It's not just that it occurs during the winter season, which makes the problem even more dramatic than we think it already is. So based on Jackie's results, we saw that the soils can retain the salt and then release it once they are wetted again with concentrations of lower salinity, and that it suggested that groundwater may be contaminated with the salt and be the source of salinity to downstream lakes, which led to her second experiment to do the groundwater testing. And what she did was we went into each of these 3 lakes where we knew there was pollution or whether it's exhibiting pollution, and we put in at these 6 sites piezometers. And a piezometer, for those of you not familiar with this instrument, is a long tube that we drive about 3 feet down into the sediment below the lake bottom, and then it's perforated at the bottom so the groundwater can penetrate into the bottom of the piezometers. And then with a pump, we pump out that water, let it refill, pump it out again, and then refill again. And then we sample this for what, in this case, we sample for chloride and conductivity to see how much of the groundwater is penetrating into the piezometer. And what Jackie found was, here's Church Lake. This is the one closest to the belt line. And then we start moving further and further away from the highway. And we have 2 different measurements here of chloride. We have the groundwater that was in the piezometer in the light blue. And then we have the surface water in the lake just above the lake the soil surface in green. And we can see that, and here's the 150 milligram per liter threshold for Michigan's chronic chloride concentration. And we can see that even though the chloride concentration does drop as you move further away from the outlet of Church Lake, it still stays well above the Michigan threshold and is clearly a source of chloride getting into these lakes. And so we think that groundwater is really the problem here. And it also indicates that our groundwater around the state might be contaminated with chloride on a fairly wide basis, wherever there's heavy salt application going on. Again, this is one site, and we have to be careful about extrapolating it. But as I'll mention in a couple of slides, we're going to be looking at this in a much broader geographic perspective this spring. So we, based on Jackie's work, we think the area is saturated with chloride from years of runoff from the beltline, and that groundwater is likely acting as a pollution pathway. So the conclusions from Jackie's study, we know that the sediments in this region have the capability to retain and release chloride, that the shallow groundwater flow paths are a likely source of the elevated chloride in this tri-lake system, and that because these de-icing salts are widely applied throughout the region, we believe that, or our hypothesis is that chloride contamination of both the surface water, the lake itself, and the groundwater may be a more common phenomenon than we know. Again, because the salt is out of sight, it's out of mind, and it's simply not tested in most locations. And then NOAA followed up. We've now documented that this is a problem, but we don't know whether the biota are being impacted by it. And NOAA decided to look at macroinvertebrates in Church and Middleborough lakes. We also did Westboro Lake, but we had some issues there. So I'm only going to present the Church and Middleborough Lake data. And he wanted to see whether there's any correlation between the macroinvertebrates and the chloride concentration in those two lakes. And in each lake, he took three different measurements of macroinvertebrates. For those of you who have studied macroinvertebrates, you know what a D net is. Basically, it's a net that's shaped like in the shape of a D, and you do sweeps through the vegetation to collect the macroinvertebrates. The Hester dendes are shown here in the lower right. These are artificial substrates that we put out in the lake for a month and let the invertebrates colonize them, and then we pull them out. And then a ponar is this device that NOAA is holding right now. It's like a big claw. We send it down to the bottom, and it does a grab of the sediment, and we bring it up and look for invertebrates in the sediment. And here we see the three different types of devices that we sampled: the DNet on the left, the ponar, which is the deepest site in the middle, and the Hester dendes, the artificial substrates on the right. And this is chloride concentration. And as you might expect, in the shallow areas, the chloride concentration is lower than the deepest area where the salt sinks to. And that is occurring here for the DNet. For the ponar, which is in the deepest site in both lakes, that's where the chloride concentration is highest. And then for the littoral zone, what we saw was that the Middleborough had higher chloride concentrations than Church. But what was the impact to the invertebrates? Well, this bubble plot shows you the main families that we measured for the macroinvertebrates. And then we have the three different sampling devices along the bottom for Church Lake and Middleborough Lake. And if you look just for the ponar, that's the deep site where that claw-like device is that captures the sediment. The only taxa families we found were chironomids and chiabrids. And these, as you can tell by the colors, are the most pollution-tolerant taxa that exists. They can handle lousy conditions. And that's really all what we found in the middle part of the lake where the salt concentration was highest. As we get out into the shallow areas, regardless of whether it's the DNet or the Hester dendes, we see more diversity, and we see taxa that are more sensitive to pollution, where the chloride concentrations tend to be a little lower. And the amphipods make up most of those. These are little scud-like organisms, little crustaceans. And then if we then regress the number of invertebrates on the y-axis against the chloride concentration, as we expected, there's a negative correlation. It's not the strongest regression. The R-squared is about 0.3, but the data are pretty clear that as chloride concentration exceeds, the only invertebrates we're seeing are from the ponar in the deepest part of the lake and the taxa that are only pollution tolerant. So a pretty clear indication that the invertebrates are negatively impacted by this chloride, and as we'd expect, that there is a biotic impact associated with this. So NOAA's conclusions: this negative correlation between the chloride concentration and macroinvertebrate numbers are certainly concerning, particularly if this is something that's occurring in a wider variety of lakes than the ones we studied. And then the next step would be to investigate chloride's pollution effect on higher trophic levels, including the amphibians, the reptiles, and the fish that are in these lakes. And we have not done those studies yet, but studies that have been done elsewhere have shown impacts of chloride concentrations to fish. So I'm going to segue here and finish up talking a little about Ottawa County and the problems we're facing in this county, which are not unique to Ottawa. In fact, as I'll show you, they're occurring all along the southern border with Indiana, Ohio, and up along the Lake Erie and Saginaw area as well. This is a different type of problem. It's occurring mostly in the middle part of the county, these four townships here, but we see it elsewhere as well. And so let's take a cross-section of the geology of Ottawa County. We have Lake Michigan here to the west. We see a lot of population density along the lakeshore, of course. And then as we go further inland, it becomes more agriculture. In Ottawa County, we grow a lot of blueberries and soy and corn. And what's happened is we have this glacial aquifer, which is pretty thin, 50 to 75 feet deep. It's really high yielding, high quality water from the glacial till left over after the glaciers receded. But below that is this clay layer. We call it an aquiclude because it prevents water from moving between these two, between the glacial aquifer and the deeper Marshall Formation. And as we're starting to basically withdraw too much water from these aquifers, we're no longer getting the pumping yields that we have historically. So now the well drillers are going deeper. They're actually drilling through the clay aquiclude down into the Marshall Formation. But the Marshall Formation sits on ancient ancient seawater. Michigan, back before the glaciers, was an ancient sea. And that brine that's down below is now starting to migrate upwards because of the pressure that the wells are applying from getting this water out of the Marshall Formation. And they're starting to get chloride, naturally occurring chloride, in higher and higher concentrations to the point where the water may no longer be usable. And so Ottawa County is facing a crisis. And if we look at the drawdown of water, they are going from 1970 in the upper layers up to 2015. The warmer the colors show, the greater the amount of drawdown. And this is in the middle of the county. We're looking at drawdown of 14 to 16 meters, 40 to 50 feet of that static water level. That's the water level in your well when the pump is no longer being applied. And there isn't a lot, we're only walking about 70 feet of glacial aquifer to work with. So we're seeing a major issue here. And not surprisingly, that drawdown correlates almost one-to-one with water use in terms of the pumpage that are going on here. But it gets even more interesting than that. Here's just a graphic showing that drawdown of 40 to 45 feet between 1960 and 2010, because people are just pumping water out faster than the water can recharge in this aquifer. This is, if you look below the dots, this is that the color heat map that I showed you of the amount of drawdown. That's basically the static water level change going on in the middle part of the county. But superimposed on top of that are the chloride concentrations in those wells. And you can see the greater the diameter of the dot, the higher the chloride concentrations. Remember, 250 here is the threshold, the Michigan threshold. And 500 is dominant throughout this whole area, and it basically overlays the areas of the deepest drawdown. So we're starting to get these chloride concentrations that are very high. If you're using it for residential drinking water, you probably can put a filter, a soft water filter on your drinking water and remove the chloride so it's usable for drinking water. It probably doesn't taste great, but it's certainly not going to cause any health concerns. But if you're a farmer and you're using high yield water, you can't use these concentrations. You're going to burn your crops. And so they're really in a difficult situation here in terms of the chloride concentrations getting near to the point where they're going to cause problems in this county, which relies very heavily on agriculture. And it's also the fastest growing county in the state. And so the development pressures are also exceedingly high. So what do we do about this? What does the county do? Well, a couple of years ago, the county, they formed an Ottawa County Groundwater Conservation Commission that I served on, and we developed a strategy for how to use groundwater sustainably in the county. And let me tell you, I think we all know that technical solutions are easier than changing human behavior. It is really tough to get people to conserve groundwater when Lake Michigan is in your, basically in your view shed. They think the water supply is endless. And so trying to convince people to conserve water is not an easy task. Our primary goal was to reduce the county's dependency on the deep bedrock aquifer system from the Marshall Formation. In other words, and to recharge the glacial drift aquifer. We wanted to come up with creative solutions to offset the new withdrawals, protect and enhance recharge of the bedrock aquifer as well as the glacial aquifer, and then embrace water conservation and reuse as much as possible. It had the overall plan had 4 major components: consistent education, basically working with all the sectors. This included agriculture, environmental, the school systems, real estate. I mean, you name it. We were having meetings with these people to explain the nature of the problem. trying as much as possible to integrate behavioral change and implement mitigation strategies. Instead of planting sod and turf grass, plant dune grass, xeriscaping, all sorts of different opportunities that people could embrace, and also with some incentives to do so, to wean them off of groundwater as an irrigation source and, water supply source. And the problem is not just in Ottawa County. As I mentioned earlier, we see this areas of high chloride concentrations along the border in Southeast Michigan, then up along the Lake Erie, Detroit River area, into the Saginaw Bay and up in the Thumb. Anywhere where the glacial till aquifer is thin. And basically, the aquifers in the state of Michigan are a series of nested bowls. So in the middle of the state, you have relatively deep glacial aquifers, but as you get out towards the edges, the glacial aquifer becomes very thin and susceptible to this kind of contamination if you're starting to pump down deep into the Marshall Formation. So what can we do about this? There are possibilities, and certainly don't want to leave people all depressed. I want to leave people with shreds of hopes about these kinds of things. Here are 8 tips. There are 4 that I'm going to show here and 4 in the next slide that homeowners can do. Once it snows, shovel often. Don't, people want to do this anyway so they don't hurt their back if they're not using a snowblower. But with less snow, it takes less salt, and the salt works more quickly. Use less salt. People over-apply salt. You really don't need to. All you need is 1 coffee cup for every 10 sidewalk squares or 2 parking spaces. The grains should be spread out. They work better being spread out than dumped closely together. Pay attention to the temperature. Rock salt only works down to 15 degrees Fahrenheit. So if it's lower than that, don't apply it because it's not going to have a benefit. In that case, you could apply sand or other types of salt. And then if you've over-applied it and you see it sitting there after the ice is gone, you can collect it, sweep it back up, and use it again. So reuse is important here. We can go to sand when there's very different, when it's very cold out, or different ice melters that work at lower temperatures. If it's slushy, remove it. Get it out of the way before it refreezes. Then you won't have to apply the salt again. And if you use a contractor to apply salt to a private road or to your driveway or to your sidewalk, talk to them. Their tendency as well is to apply more salt that's necessary to make sure that you think they're doing a good job. And it's just like fertilizer. You apply more than you need, and all you're going to do is create problems. There's only so much salt that's going to work, and only so much fertilizer that a plant can take up. And spread the word. Talk to your neighbors, community meetings. Wisconsin is way ahead of us in Michigan in terms of being salt-wise. They've got this great website that has lots of information in case you're interested in following up on that. The hope is, Eagle's starting to become much more aware of this. And hopefully this is something, and webinars like this, getting the word out is really critical. Brine, ironically, a problem in the deeper aquifers can actually be a benefit if it's applied before the snow occurs. It makes the snow and ice stick to the surface more effectively. And so if you see this brine application going on our roads, you'll know exactly why they're doing that. The salt brine is effective to -6 Fahrenheit. And so it can work at much colder temperatures. And by doing so, it not only reduces the cost of maintaining the road, but also keeps the salt on the road. Other solutions, a lab study that was just published last month looking at salt contamination in a lake near Kalamazoo, removed chloride from the lake water. It was done in the laboratory. It wasn't done in the lake itself, using this Friedel salt precipitation procedure. Basically, you add calcium oxide and sodium aluminate to the salt in the water, and it precipitates it out. They are doing a field testing this winter, not in the lake, but in basically there's a small retention pond next to the lake, and they're seeing how well it works. Eagle is out there monitoring with them, giving them the permit to do this. I've been talking to these people to see whether it could be applied elsewhere, if it does work there. So it's something we don't know if it could be scaled up. We don't know how well it'll work in situ, but at least it gives us some hope. This is what basically it looks like. And I take this directly from the study that was published. And you can see on the right the devices they used in the lab in order to precipitate out the salt. Don't have a good idea of the cost effectiveness if it does work, but certainly looking for different strategies that can work to make sure that if this problem is more widespread than we think, we need to start thinking about modular solutions to deal with this. So overall conclusions and next steps. One, we can see that salt contamination is insidious, at least in my opinion, and potentially a common problem in Michigan lakes. This spring, we're going to start a lake survey in 5 West Michigan counties, 50 to 75 lakes, looking at chloride concentration, phosphorus concentration, and proximity to major roadways. And then in consultation with MSU Extension and our local planning organization, the West Michigan Shoreline Regional Development Commission, will spread the results so people can be more aware of this problem, assuming that it is actually problematic, because we don't want to just internalize these results. We want to make sure that it gets out and people can appreciate the problem that they may be facing. And just want to acknowledge the people whose work I've talked about, Jackie, Ellen, Noah, and Allison, and then a lot of different funding sources. And my incredible lab has been involved in this from the beginning, and then the families that gave us access to lakes. And I give them a lot of credit because basically, we're doing studies that can hurt their residential home value, and yet they're interested in making sure that they understand the nature of the problem and how it can be solved. So thanks to them as well. And with that, I will turn it back to Heather. I will stop sharing and see if there are any questions. And thank you for your attention.
Thanks, Al. Those studies were really, really interesting. And I found a lot, I just listening and kind of trying to still probably digest some stuff, but there's a lot of correlation between questions that our staff and that we're asked by our membership and lakefront landowners or riverfront landowners as well. So lots of application, like you were saying, across the state, across the region. I do have a couple of questions coming in. First, we thought maybe you could talk about maybe kind of going back to the beginning. What's the difference, or is there a difference between road salting and road brining? And is one maybe less polluting than the other?
Well, brine is a concentrated salt. That's all it is. So as a consequence, because it is concentrated, it tends to work at lower temperatures. So that's the benefit of it. Other people, in addition to the brining, have talked about using beet extract juices. Anytime you're talking about an organic material to work as opposed to chloride, you can see the benefit, but adding organic sugars to our lakes can also stimulate bacteria and fungi. So there's, the law of unintended consequences that are just going to bite you in the butt every time. So unfortunately, there's no universal solution, no universal panacea. If there was, we'd be applying it right now. So they all come with different costs and benefits. I think the most important thing at this point is to educate the public, educate our local county departments of transportation, so that they're aware of this issue and start thinking about ways that they can mitigate.
So we talk about, the road salting and brining being the biggest kind of contributors to this kind of pollution to our water resources. But you did mention water softeners too in the beginning. So are there other options that you know of, or that we can maybe find for folks that are salt-free for water softeners? Because we have really hard water, so I know there's lots of water softeners in the region.
I don't think the answer is substituting the salts for the softening. I think it's the discharge of the softeners that we need to be more. If it's going into sanitary waste systems, then it's not going to be a problem. But if it's, for example, if you're on a septic system, obviously then you have the potential, unless you're maintaining the septic system on a regular basis, which unfortunately we know doesn't occur on a regular basis in Michigan, then it has the potential to get into the groundwater along with nutrients and E. coli and other nasties. So ideally, if it goes to a sanitary water treatment system, it won't be a problem. If you are on septic, then please maintain it, get it pumped out every 3 to 5 years, and make sure that you don't have any problems with the leach field getting into the waterways.
Yeah, perfect. So many connections between this challenge and a lot of the other challenges that we're all trying to kind of move the needle on, right? So the connection between salt pollution and harmful algal blooms, I think is really important for us to pay attention to, or the potential for harmful algal blooms, right? We have a question related to that a little bit, and whether or not you think that there could be any correlation between high phosphorus from maybe road salt contamination and the trouble that we've seen in the eastern Lake Erie, or even on some other inland lakes.
I don't think that would necessarily be an issue. It's an interesting question. I think the problem, the phosphorus has to come from somewhere to begin with, to be excess, right? In case of Lake Erie, and in case of a lot of our drowned river mouth lakes, it's coming from agriculture, at least in the southern part of the state where ag is more prominent. And then, it runs off into these lakes. Then if salt gets into the system, those nutrients will stay at the bottom, and that's the problem. And they'll basically concentrate down there until the lake turns over. So, in some cases, the phosphorus is naturally occurring. We do have high phosphorus in our soils around here. So I am not trying to attack the agricultural sector. I love blueberries. I want to eat, on a regular basis. And, the vast majority of our producers are good stewards of the environment. It's in their best interest. But you do get people, you do get farms that are not as well maintained as others. And we just need to be aware of that and work with them so that the best management practices that are applying, whether it's nutrients or whether it's salt or any potential contaminant, is maintained and contained as best as possible.
Yeah, excellent. So another question regarding your student studies, I should say. This person, Sylvia, is excited to hear about people exploring that connection between groundwater and surface water and that interaction with chloride. So she asks if it's in regards to biochemical pathways and trophic absorption for chloride and salt elements. And does this research demonstrate any trends that impact the capacity for restoration in some of these systems?
Oh, absolutely. I think we need to be really cautious about where we're restoring and what we're restoring. And I'm preaching to the choir with Sylvia, but in this case, we need to make sure that we do the preliminary analyses so that we spend a little money on the upfront science to make sure that we don't waste a lot of money afterwards on a restoration that's either not going to work at all or it's going to exacerbate the problem. And, restoring wetlands is a great example. And, we can talk about what's going on in the Lake Erie Basin as a great example of that as well. If you have a prior land use of heavy agriculture, and here in West Michigan, we see a lot of our drowned river mouths were former celery fields, right? The wetlands were drained. The Dutch all moved in, they drained the wetlands. They're good at doing that, and then planted celery and things like that. And then when it no longer became viable to farm celery, they turned off the pumps. These wetlands filled up with heavy phosphorus concentrations. If we just start take out the dikes and let all that nutrient-rich water move into our drowned river lakes and into Lake Erie, Lake Michigan, whatever it might be, we're going to make the problem a lot worse. So doing a little work at the front end to see what the nature of the problem is and solve that problem before we restore, I think it just makes all that sense. And salt is another great example of that. If we don't know that salt is sitting at the bottom of a lake and we start doing stuff to artificially turn over the lake, not knowing that the salt is there, we can create all sorts of problems as well. And that's why we're trying to do this survey. And ideally, assuming that we find that this is more problematic than we currently know, it's a survey that would go statewide. And let's see where this problem is. We're also doing the GIS analysis to see what factors are most relevant to cause salt problems in these lakes. Is it proximity to a major highway? Is it having a surface connection? Is it the land use around there? I mean, all sorts of parameters will go into our GIS analysis to figure out what factors are most important in resulting in salt contamination, assuming that it's occurring.
So related to this survey, this upcoming survey, which do you have all the lakes identified, or lakes in which counties are going to be in that survey?
We're doing the GIS analysis right now.
Okay.
We have an initial list of 80 lakes. We have certain criteria that we've put into. I mean, there are many more than 80 lakes in our 5-county region, but we need to make sure it's deep enough to stratify naturally. We need to make sure that there's boat access, just out of making sure that the logistics are going to work. And we want to make sure that it's not so distant from any roads that it just doesn't make any sense to do it, So there are certain criteria that we use as a screening tool. And again, the work that Hillary has done over in Wisconsin has been just so critical for us. And we've chatted with her as well, and she's been a great resource as well. Like I said, the folks in Wisconsin are really, miles ahead of us, and we're just trying to catch up at this point.
So you mentioned that 5-county region, that's the planning region, right? So that's Ottawa County, Allegan.
It's not Ottawa. No,
Doesn't
no,
go
no.
down. Oh,
No,
sorry.
it's Muskegon, Oceana, Lake, Newaygo, and Kent.
Thanks. Can you, I'm just looking through some of these other questions. So can you speak to at all how impactful the brine on gravel roads in warm weather is to keep dust down? Is that, I'm not even sure if that's salted brine or if that's some other sort of brine that road commissions use.
There is salt in that they use.
Okay.
I don't know. That's a really good question. I have not seen anything in any of the literature that has examined that brine to see whether the runoff from that might also be a source of contamination. I mean, obviously, the dirt roads need to be contained in one way or another, and they're looking for the cheapest way to do that. And I understand that the road commissions, we're all constrained by financial resources. So it may behoove taking a look at that in the future. I can't imagine that it's going to be a massive problem compared to some of the other potential sources, but I don't know. And so I appreciate whomever brought that up. I appreciate that question. And if we get a chance, we'll take a look at that as well.
Yeah, lots of things to keep on the horizon. So I'll just do one last question that maybe kind of helps us sum things up since we're getting close to 1 o'clock. Maybe we've talked a little bit about other freshwater challenges and issues here in the state and their like correlation maybe to salt problems. But if there are other maybe notable issues that you want to make sure that folks hear about or start thinking about.
Oh, you just want me to depress people more.
Just
Thanks,
everything.
Heather. Thanks, Heather. I appreciate it. That's great. Well, I mean, nutrients obviously are a major concern, right? And, it's not just Lake Erie. Lake Erie gets all the attention, sometimes Saginaw Bay, sometimes Green Bay. But the reality is our drowned river mouth systems, even the cleanest water ones, whether you're in Harbor Springs or down in Lake Macatawa on the west side of the state, they are subject. We're starting to see harmful algal blooms in Lake Superior, where we never would have thought that they occurred in the past, because these nutrients are coming off the watershed and they're getting into the system. So I think we all need to be more aware of that problem, do what we can, particularly homes that are on septic systems, which is half the state. They need to be maintaining, and it's unfortunate, of course, that the legislation that the legislature was looking at that this past session, it didn't pass, but this is something that we need to be thinking about and addressing in the future. We really need to we're the only state in the country that doesn't have a septic code. It's absurd. So yeah, we need to take a deeper look at that.
Yeah, thanks. So I will just put a quick sort of, plug in for our staff. Took advantage of Wisconsin's Saltwise program as well. So we joined in the initiative, part of the reason you're here today also. But so we do have a lot of Saltwise information on our website, I believe, as well, or folks can reach out to us and we can connect people to the staff working on some chloride challenges in our region and other Saltwise resources too. So we're hoping to help get at least some of our local communities on board with us. So
great, that's fantastic.
Yeah.
Well, I'll wrap it up for us here. Thank you so much. I know you said call you Al, but I just can't not call you Dr. Steinman. I'll quickly just share a little information about our upcoming lectures. And again, I can't thank you enough for your time. That was equally interesting as it was terrifying to listen to. So thank you so much, Dr. Steinman.
You're welcome, I think.
Right. Okay, so just a reminder, we have one final Icebreaker coming up on March 25th, where we'll be talking about climate change and taking action, and maybe some challenges or barriers to what's keeping us from taking action on that, with Peter Scholes. And just mark your calendars. This June, we will be hosting our Linking Lakes event. It'll be at North Central Michigan College. This is open to members of lake associations in our service area to really come together and learn about what projects we're working on and how we might be able to collaborate. Again, for our people joining us from the Burt Lake Watershed, we are offering our Greenbelt Cost Share program, where we'll cover up to half of the cost of your Greenbelt installation, up to $2,000. So please take advantage of that program to secure some free funding for your waterfront home. And of course, we're always looking for volunteers. We get them out in the water if you want to be hands-on, or in the office stuffing envelopes. We can use volunteers for just about everything we do. So consider joining us as a volunteer. And lastly, and nothing we do is possible without the support of our donors and members. Thank you so much. And if you are not a member, please consider joining us to be a part of keeping our lakes and rivers healthy and clean in Northern Michigan. So thank you so much. And thank you for joining us today, Heather. A nice way for everyone to meet you as well. So Dr. Steinman, thank you again. Heather, thank you. And we hope we see you all in March.
Thanks, everybody.